So these types of problems that we've been talking about, these actually have a name. And you're going to see this come up a lot in algebra too. And hopefully you learned this name last year, but it's been a while, even if you did. These types of problems are called difference of squares. Difference meaning it's got subtraction. Okay, so this only works if there's a minus between your two terms. And squares meaning that there is something that multiplies by itself. A perfect square is something where you can think of something that multiplies by itself to get this. Like b squared is b times b. 25 is a perfect square because you can write 25 as 5 times 5. Is 12 a perfect square? Are there two integers that multiply by themselves I'm sorry, is there an integer that can multiply by itself to give you 12? No, you could do 3 times 4, but those aren't the same numbers, right? 2 times 6, but that's not the same number. So 12 is not a perfect square, but 25 is. What are some other perfect squares? 36 is a perfect square. That's 6 times 6. What else? 49 is 7 times 7. 64 is 8 times 8. 1 is one of the ones that people forget about. 1 is 1 times 1. 0 is technically a perfect square too, isn't it? 0 times 0. So I want you to start looking for these. If you see two perfect squares, so b squared is a perfect square because it's b times b, and 25 is also because it's 5 times 5. And it must have a minus between. This does not work if there's a plus in between, okay? Only if there's a minus in between. This is called a difference of squares. I'm going to write that down here, and I'd encourage you to write that down too. Difference of squares. And if that's the case, then you don't have to do a whole lot of work to write down the answer. You just write it down. It's always going to be in this framework. You will have two factors. One of them will be a plus and one will be a minus. It doesn't matter which order the plus and the minus come in. Wow, that looks a lot like you're messing around with the phone. Is that what you're doing? Could you put it in your bag, please? Thank you. Appreciate it. And then go back and think about what were your perfect squares and what were your building blocks. B squared was b times b. So we're going to get a b in each of our factors. 25 was 5 times 5. So we'll get a 5 in each of our factors. And that's it. We don't need to do any work or anything. We just need to recognize it. This is one of those shortcuts where you're like, oh, that's one of those difference of squares things. And then you could just go straight to the answer for it. So our first 6 problems are all difference of squares. If you haven't already, go ahead and complete those first 6, and then we're going to talk about how to complete the rest of them. I'm going to kind of quietly work through a couple more up here. So if you're still a little bit confused, feel free to look at the screen. If you've already got those first 6 done, then just check your work and sit tight. We'll get back together here in a second. Question. Still working on it. Yep, thanks for your patience. All right, are we feeling pretty good about these difference of square problems? Show me on your thumb meter right now. If I give you a test full of these, how are you going to do on them? Do you feel like you can recognize them and get them done pretty quickly? you're gonna love, you're eventually when you get into algebra 2, you're gonna love when this comes up because this is like the easy factoring, not the easy, but the fast anyways. Okay, so we're doing both ends of the spectrum, some of the more simple factoring, and now we are going to go on to some of the more difficult factoring. So I really need your attention as we go over numbers 7 and 8 together. Because there's a pretty long process to do this. Now, there are other ways to do this, and I will go through and show you some of my shortcuts that I have learned over time. But this is the method that we teach in most of our Algebra 1 classes and continue to teach in our Algebra 2 classes. And it works. Can I get your attention, please? So save the side conversations for later. This method is nice because it works 100% of the time. Okay, you can always do the exact same steps over and over and over again. They just it takes quite a while to do it. Okay, so for those of you that are interested in some shortcuts, get my attention later and I'll show you some. All right, so we started learning this the other day. Do you guys remember how before we were writing out values for A, B, and C? So let's go ahead and do that again. We're going to follow the same steps that we started with when we were learning this on Friday. So A is going to be 5. A is going to always be the coefficient in front of your squared term. B will be the coefficient on your linear term, the term without the square. It's -16 this time. And C is going to be your constant. And that's 12. A, B, and C never have a variable in them. They're always just numbers, okay? Sometimes people want to put an X, especially on the B, but there's no X's on these things. Just the numbers, just the coefficients. Okay, and then we are going to create a X or diamond problem out of this, just like we did on Friday. So this is going to follow that same process. And just as a reminder, we're going to put A times C on the top and B on the bottom. So for this problem, we've got 5 times 12 for A times C. That's 60 on the top. And B is -16. That's going to go on the bottom. And our next step is going to be to solve this diamond or X problem, just like we did before. So far, nothing different from what we've done. It's the last step that's a little tedious. Just as a reminder, you're trying to find two numbers that multiply to give you the number in the top and add to give you the number in the bottom. So I'm trying to find myself two numbers that are going to multiply to give me 60 and add to give me -16. So 6 and 10 could work, except those add up to +16. Could we make them both negative? -6 and -10, would that still multiply to give us a +60 up top? Yeah, so anytime I see a positive number in the top, I know that these are either both going to be positive or both going to be negative. And I think in this case, we want them both negative, right? So we had a suggestion for 6 and 10. I think that'll work if we make them both negative. So -6 and -10. And the question came up on Friday last week. Does it matter whether you put the 6 here and the 10 here? Can you reverse them? And the answer is it doesn't really matter as long as they add up and multiply. We feeling good so far? All right, this is where we're going to branch off because on Friday, I told you that if A was 1, we could just use these in our final answer. But A is not 1, so we can't do that shortcut anymore. So now we have to do the last piece, which is the box. So we're going to come over here, leave a little bit of space to the left and above because we're going to put some stuff on the top and on the sides. And this is going to be the hardest part to remember how to do. This process is how to fill out the inside of the box. Okay. Once you practice it a little bit, it's not that difficult, but at first it's going to be difficult to remember how to do. So I'm going to kind of draw some arrows. Let me get some colored markers so I can sort of color code these. So from the original problem, your first term and your last term are both going to go into the box. Okay. The first term is going to go in that spot right there. And your last term is going to go in that spot right there. Okay, so we're going to end up with a 5x squared right there and a 12 right there. The whole term goes in those two spots. Okay, it's always going to come from your first and last term in your original problem. First and last term go in those two spots. And those do need to end up in the right places. The other two parts are going to come from your x. They're going to come from the answers we got in the x. This -6 and this -10 are going to go in these two spots. And they're both going to get a variable after them. We're using x's in this problem, so it's going to be -6x and -10x. So -6x and -10x. How many people are seeing something that looks familiar to them right now? Do you guys remember kind of learning about this a little bit last year? It's probably right at the end of the year, and it was probably really short. You've seen it before? Cool. All right, and if you've never seen it before, if it was so fast that you're like, I don't think I've seen it before, it's okay. Because that's the hardest part of it really right there. It's just filling out the inside of the box. So I'm going to go ahead and make myself a little arrow here as well. It tells me that the diagonals go from those answers. Okay, now what we need to do is, this is like one of those boxes. We need to fill out the numbers on the sides and the top. So we're kind of working backwards from a box problem. So what I like to do is look at my top row here. And I like to ask myself, what is something that I can multiply to equal both 5x squared and -10x? What do they have in common? Think about the 5 and the 10. What do 5 and 10 have in common? I would say that you can use a 5 to multiply and get both of those numbers. Would you agree? 5 goes into both of those. So I'm going to put a 5 out front. Also, notice that they both have x's in them. Now this one has 2 x's and this only has 1. But I would say we could multiply a single x to equal both of those also. So I'm going to put a 5x out front. That's kind of the trickiest part. Anybody have any questions about how I got that 5x? I was kind of looking at the 5 and the 10 and I said, oh, I can multiply a 5 to make both of those. Once we get this, then go ahead and fill out what the top needs to be. What would I need to put up here so that multiplied by 5x to get 5x squared? What do I need up here? 5 times 1 would get me the 5, right? And then what else do I need? X times what gives me x squared? 1x. So 5x times 1x would give me 5x squared. Nice. What would I need to put up here so that when I multiplied 5x times it, I get -10x? 2? Or did you say 2 or -2? You said -2, and that's good. We would need the negative, right? And then same thing down here. What would I have to put down here? I noticed that it's multiplying times 1x to give me -6x. -6. And just double check that the 12 is going to be correct. Are we going to get 12 if we multiply that -6 times that -2? Totally. All right, then we're done. We have finished the problem. Final answer is x minus 2 times 5x minus 6. If you would prefer to write that in the opposite order, that is also a viable answer. All right, you see what I mean by this being kind of a long process? It takes a little while. Again, there are shortcuts, but for right now, I want you to learn how to do this method. Reason is, even though I know shortcuts, when I get to some really nasty ones, like where this number out here is like a 3-digit number or something like that, my shortcuts don't help me anymore. The bigger the number I'll fall back on this. Okay. So let's go through again. Let's do another one together. Just know that these will get faster as you get better at them. So, all right, so we got A, B, and C. Can we go ahead and skip writing out the A, B, and C and go straight to our X? Remind yourself that it's A times C in the top and B in the bottom. So what is A times C? What is 2 times negative 56? Negative 112. Ooh, that's a big number. And B is what? 9. I think I'm going to want a calculator for this. I'm trying to find things that multiply to give me 112 and negative 112 and add up to give me 9. Now I know because it's a negative that I'm going to need one positive and one negative number. Oh, calculators disappeared. Is this one? Hey. So I'm going to start with 112, and I'll just start dividing it by some different stuff. Someone give me a good guess. What goes into 112? 3? Let's try 3. 3 doesn't work. No. 6? No. Keep guessing. I'll tell you that if 3 doesn't work, then no multiples of 3 are going to work either. So there's no point in trying 9 or 12 or 15 or any of those other multiples of 3. 2 and 56. Is there any way I can add a 2 and a 56, making one of them negative and get 9? No, I need something bigger than 2. Give me something bigger than 2. 7 and 16. Ooh, is there a way I could? So I did 112 divided by 7 and got 16. That means 7 and 16 would multiply to 112. Can you think of a way to add or subtract 7 and 16 to get 9? If we made the 7 negative and the 16 positive, I think that's going to work, isn't it? If I did negative 7 plus 16, that's 9. And negative 7 times 16 is negative. Hey, all right. So it's negative 7 and 16. So sometimes we got to break out a calculator and just take that number on the top and start dividing it by some stuff and see if you can find some whole numbers that are going to get you what we want. All right. This is the big memorization part. Can you remember where all the pieces go? See if you can do that on your own. I need you to fill in all 4 spots in that box. That 2k squared should have gone somewhere in there along with the negative 56. Did you put those 2 pieces in first? Those come from our original trinomial. And then that negative 7, 16 that we just came up with are going to go in as well, but they both get k's this time. Last time they got x's, but this time our problem is dealing with k's, so they're going to get k's. Were you guys able to get those 4 things on the inside? All right, from here we're on easy street. Tell me, what does a 2 and a 16 have in common? What's a number that I can multiply to make both 2 and 16? 2. I can multiply 2 into both of them. And then see how they both have k's? I'm going to put a k out here as well. 2k. And then you just need to fill out the rest of the pieces. What would multiply by 2k to get 2k squared? That would be 1k, wouldn't it? 2k times 1k is 2k squared. 2k times something would be 816k. Morning. I think that's an 8, isn't it? Good morning. Aren't these the best? Thank you. You gotcha. And then what do we need on the bottom there? What multiplies by 1k to give us negative 7k? Negative 7. And then double check this last number is your final check. If this works out, then you've done everything correctly. Is negative 7 times 8 negative 56? Woo! All right, so we're done with this problem. We got k plus 8 for our first factor, and 2k minus 7 for our second factor. If you'd like to leave that 1 in front of that k, that's all right, but it's not really necessary. Okay. How are you going to get quick at these? You're going to get quick at these by practicing them. So that's going to be your work for the remainder of our period today. We are running on a reduced schedule today, so we will be leaving here at 8:25. That gives us 13 minutes. Can you do them all in 13 minutes? Sure. Yeah, I can. Any questions? You want the shortcut? I'll show you the shortcut. You really want the shortcut? I don't know if you're going to agree that it's a shortcut. Well, I'll show you on number 9. So this is not due today. No, it'll be due on Monday. I'll show you how I would do these problems in a quicker manner. This relies on having some really good mental math. I know that my answer is going to look something like this. I should be using pencil because I'll probably need to erase. What I know is that whatever I put here and whatever I put here have to multiply to give me that first term there. And I only know one way to make 2m squared. That's 2m and 1m. This is the only way to make 2m squared. So I know that one of my factors is going to have a 2m and one of them is going to have a 1m. Okay. Now, I also know that whatever goes here and here have to multiply to give me 35. And I only know 2 options to make that happen. It's either 1 and 35 or 5 and 7. I'm going to guess it's probably 5 and 7. Now, the thing is, I don't know whether the 5 goes here or the 7 goes here. Whatever goes here, the other one's going to have to go here. So I got to do a little guess and check. So I'm going to start by thinking 5 here and 7 here. Okay, and I'm not even worried about pluses or minuses right now. I'm going to do, remember my little face thing that I showed you guys? The nose and the mouth on the face. This nose and the mouth have to add up to give me this 17m somehow. So right now I got 5 times 1m is 5m, 2m times 7 is 14m, and I'm thinking to myself, is there any way I can add a 5m and a 14m to get to a 17m? Answer is no. So maybe I flip these. Now it could be 1 and 35. I'm guessing probably not, but I'll try flipping these. That's going to change these. This is now a 7m and this is a 10m. Is there any way I can add a 7n and a 10m to get 17m? Absolutely. Now I think they both need to be negative, don't they? Which means this needs to be a minus. But they're adding. So they both need to be negative. Also, it needs to multiply to give positive 35. So they both have to have the same sign. So there we go. I got to my answer without having to do any X's or boxes or anything like that. And I did it just kind of by guessing and checking. Now, when this number comes out to be something like, I don't see any terrible ones on here. 16. There's quite a few ways to make 2 and 4, or 2 and 8, or 4 and 4. When it comes out to be something like 24, and you got 3 and 8, and 6 and 4, and 2 and 12, you got a lot more. Remember, and you can flip them around too. Also, 100, yeah. There's some different ways to get 100. 4 and 25, 2 and 50. So you might have to try several things. Also, if there's more than one way to get the first term, then things get pretty complicated, like the number of possibilities get complicated. There is, and I designed these problems so that they would only have one way. But if this had been a 4x squared, then I wouldn't, like, this is a 2x squared. If this had been a 4x squared, I wouldn't know for sure whether this was 1x and 4x or 2x and 2x. So you'd have a lot, you could potentially be guessing and checking a lot further. So this is generally quicker, especially if you get lucky and you get to it on your first guess. But even if you've got to go through a few iterations, and if you're pretty good at mental math, usually I don't actually write these down. I'm kind of thinking through them in my head. So that's the shortcut. I don't know if it's much of a shortcut. I still, though, if I get big numbers, I go back to this thing that I showed you today. If I get something with big numbers, especially if there's like multiple ways to get this and multiple ways to get this, I'm probably going to go back to this because it's going to end up being faster in the long run. So I want you to be able to do this method for sure.
from last week, so on Thursday.
On Friday, yeah, and we said to stop there, so that's good. Yep.
Okay.
Yep, do you mind if I borrow these and put them up on the screen?
Yeah.
Thanks. And I'll turn them in.